All right, everybody, we're on 4.4 now, the fundamental theorem of calculus, so very, very important. This is what it states. Basically, this is taken right out of the book. If f of x is a function that is continuous, this is important, on the interval ab, and capital F of x is the antiderivative of lowercase f of x on ab, then the integral from a to b of f of x dx is equal to the value of the antiderivative, f of b, minus the value of the antiderivative evaluated at a, f of a. So it gives us instead of doing rectangles to find the area under the curve, this is the shortcut. I shouldn't say shortcut. This is a faster way to do it. So a couple of things that we have to talk about first before we get into it. You will see some notation, new type of notation. So integral of f of x dx before you do the evaluation part. So you have to distinguish between lowercase and capital case f. This is how you can write the notation. So this says evaluate f of x, capital F of x, from b to a, which means you put in b first and you subtract the value of the function at a. Second thing is you'll notice there is no plus c in any of these, okay? Because we don't need it. And this is why. Don't need constant of integration. And so if I evaluate this, I'm going to go integral integral a to b of f of x dx. So if you evaluate that, what we've been saying is it would be the antiderivative plus your constant of integration, which would mean it would be f of x, sorry, f of b plus c minus f of a plus c. And you can see c minus c would go away. You're just left with f of b minus f of a. Okay, so we don't need a constant of integration when you are doing definite integrals. Definite integrals are ones with numbers. Definite integral. If they don't have any bounds, then it's an indefinite integral, and you have to put your constant of integration. All right, so let's start doing some practice ones here. So integral from 1 to 2 of x squared minus 3 dx. So first step, find the antiderivative. Well, that's going to be cubed over 3 minus 3x. We're going to evaluate that from 1 to 2. So 2 minus, and then you put in the 1, so it's 1/3 minus 3. So I get 8 over 3 minus 6 minus 1/3 plus 3. 8 over 3 minus 1/3, that's going to give me 7 over 3. Negative 6 plus 3 is minus 3. Find a common denominator. 7 over 3 minus 9 over 3 is equal to negative 2/3. The value of that integral is negative 2/3. That's a lot faster than doing the rectangle method. Okay, 2. Integral from 1 to 4 of 3 root x dx. Okay, so you know the 3 can come out. We rewrite the root x as x to the 1, and then we evaluate it. constant just follows. Either 1/2 is going to be add 1, so 2 over 2. So I'm going to get x to the 3/2. Divide by 3/2. And we're evaluating that from 1 to 4. Okay, well, that and that go away. The 2 flips up, so really I'm getting 2x to the 3/2 evaluated from 1 to 4. Excuse me. So it's 2, 4 to the 3/2 minus 2 times 1 to the 3/2. 4 to the power of a half means square root. Square root of 4 is 2. Cube it, get 8. 8 times, so that's 16 minus 2, which is 14. So what that really means is 2x. So my square root graph looks like that. Between 1 and 4, that area is 14. All right, number 3. Do a simple trig one here. 0 pi over 2 sine x dx. So essentially, what's the integral of sine? Well, negative cos x evaluated from 0 to pi over 2, which is negative cos pi over 2 minus, watch your signs. This is the only time it can get tricky. It's always subtracting, but there's already a negative on the cosine. So cos of pi over 2, if you remember the cos graph, pi over 2 there is 0. That's 0 minus cos of 0 is 1. It's negative 1. So that negative. So the answer is just 1. Which means if you have a sine graph, 0, that area there is 1. All right. Okay, this would be the point in the class where I stop, and I would say, please go to page 288 through 5 to 29 odd, but not 23 and 25. That's the next example I'm going to do, those two types, absolute values. So take a break, stop the video, try those questions, and come back to the video. All right, everybody. So I'll do it in a different color just to distinguish the second part. I like the red here, the maroon. So example number 4. I said we are going to do an absolute value. So let's do from 0 to 2, the absolute value of x minus 1. Okay. Now, absolute values are tricky. Can't just integrate them straight away. Because if you think about it, this graph looks like this. It has a 0 at 1. And you guys know